glad to see all of you here today. An astounding 50% of all Pima adults have diabetes type 2. It is the leading cause of death and disability in the Pima Reservation and the major medical contributing factor to other illnesses and costs that make this disease the #1 disease center for diabetes in the world. Since 1940, the rate of diabetes has increased from 9% to 50% and more. According to studies done by Eaton Boyd and Melvin Kenner in 1988 in the American Journal of Medicine, there's a hypothesis that the thrifty gene, which was initially predicted in 1962, was responsible for this rapid increase in the rate of diabetes. My purpose here today is to acquaint you with the thrifty gene theory, to give you some information about how the thrifty gene interacts with nutrition and diet for the Pima Indians, and how it contributes to the factors of diabetes type 2, a chronic lifelong disease that basically acts by taking the insulin hormone synthesized by the human body and rendering it unusable by the type 2 diabetic. This hormone controls blood sugars and regulates the blood sugar level in the body. Well, why do we need to know this? Because more and more genetically affected or impacted diseases like diabetes type 2 and now diabetes type 1, leukemia to some extent, and even cancer have been shown to be linked to the genetics as opposed to the medical model. The medical model is changing to look at more genetic factors in populations and groups, and in the case of the Pima Indian, it's really critical to know why this is happening. Now, there's a few things that you might want to know about the term thrifty gene theory. The thrifty gene theory was first presented by Dr. James Neal in 1962 in a journal article. It hypothesized that the Pima fat storage increased during times of plenty in anticipation of famine. This happened as a genetic adaptation, and his theory stated that basically this adaptation occurred over thousands of years as the body learned to prepare for famine by storage of fat. His theory really states that the ancient metabolism of the Pima interdicts modern dietary and nutritional systems in a disastrous way, that the Pima's economical and efficient system meets crisis when it encounters the contemporary foods we have in today's diet. Put simply, the effect of the thrifty gene is to eat less food, store more fat, burn it more efficiently, and run blood sugars up incredibly high. Let's look at the term ancestral diet. Ancestral diet for the Pima consisted of these elements: anasazi beans, tepary beans, chia seed, mesquite, choya, agave, saguaro, and lean meats. The lean meats were usually small rodents and desert animals and occasionally antelope from the higher plains. Their food came from hunting, agricultural farming, and so on. These were primary ancestral plants. The thing they have in common, and these are some of the plants here, this is mesquite, this is the cactus, and this is the tepary bean in its harvested form, done by courtesy of my artist daughter. The thing they have in common is that they all have soluble fibers. These soluble fibers produce a gel, which makes complex carbohydrate forms that regulate and slow down the metabolism of sugar and starch. In other words, they are a lean food compared to today's beans. The ancient Pima ate about 5 times more of these elements than they do today, according to studies done by Thomas Sheridan and Nancy Perez in 1966 in Path to Life, which is the contemporary guide to anthropology used by the University of Arizona and most colleges. The meat factors really had very little to do with the nutrition standards, except they were low fat and quite lean compared to today's Now that we've discussed the ancestral diet, what do we mean by the contemporary diet? The contemporary Pima diet really has gone through two phases. The first phase is from 1700 to 1860, when the Spanish and Europeans first introduced beef, melons, and wheat to the Pima. The Pima cultivated the wheat and extensively used it in bread products. From 1860 to present was the second period of development of contemporary diet. This happened when the rivers dried up, when the white men essentially of the Western civilization took the water rights and the agronomy from the Pima. And the result was that they had to import Western and Hispanic foods into their tribal organization. These included lard, butter, refined sugar, white flour, corn, rice, fast-burning beans, and fatty meats like pork. Western foods had a number of qualities that were similar as well. And those qualities were they were low quality, often issued by government food programs. They were low cost, high sugar, and high fat, resulting in increased levels of sugar and fat being stored, increased levels of sugar being burned at a higher rate than the original lean diet. What are the effects of this dietary change in relationship to the thrifty gene? Well, according to Lorraine Merchant, in a study of the Department of Health and Human Services of the United States government in 2010, she found that the 1940 studies were normal levels of diabetes among the Pima, and it equated to the national level of diabetes among Americans as well. There's been a 5.5 times increase in diabetes in that period of time. Now it is accepted as theory that the lean gene theory, the thrifty gene, also called lean gene, contributes to diabetes in Pima and other native populations. So it's now part of the medical model, and treatment methods and medications differ as a result of that identification. So we know that there's fact in this finding. Now let's summarize the thrifty gene terms and expressions we've discussed. We talked about the thrifty gene, we talked about ancestral diet, we talked about contemporary diet. Let's proceed on to the conclusion. We presented a number of concepts regarding the thrifty gene theory and its relation to diabetes for the Pima Indian. I hope that you're all able to leave with an idea of ancient cultures and what happens to them when they intersect contemporary cultures, much like what happened with James Cook and the Cook Islanders, where 2/3 of the population died of measles within a short period of time. Disastrous effects can happen when these two cultural aspects intersect. And this is a factor that we understand in genetic agitation, where it may not be clearly understood why the Pimas are gaining every year in the level of diabetes. We do understand it is happening. We understand some of the contributing factors. We do know, for example, and it's very important to realize that now we're seeing higher incidence of type 1 diabetes in Pima infants. We're seeing higher levels of leukemia and high levels of cancer in young Pimas than we ever did. And it has been suggested that the lean gene theory, or the thrifty gene theory, may also intersect into these areas. So it is important that we gain a better working understanding of this model. I want to thank you all for coming. I appreciate you being here. There are samples and menus of the lean gene foods in the kitchen. Thank you.